equals 18. Okay, just like before, previous problem, we're going to take a square root of both sides, square root of x squared plus or minus the square root of 18. Now 18 is not a perfect square. I think I might have sent you the squares and square roots reference sheet.
Yes, yeah.
And some of them work, some of them don't. Okay, so the ones that don't work, like this one, you have to break apart. And I think we did a lesson at some point on this where you build a factor tree. Do you remember us doing that, or is that?
No, I don't think we've done that yet.
Okay, so this is kind of its own mini lesson. Factor tree deals with prime numbers. It's actually a prime factorization. Smallest prime number is 2, then 3, then 5, then 7. The list goes on forever. You don't need to remember more than these, but you do have to remember at least 2 and 3 and 5, maybe 7. So what you do is you write 2 and you try to figure out what do you multiply 2 by to get back to 18. The answer is 9. Okay.
Okay.
And then you try 2 again and you're like, well, 2 doesn't work, but 3 does. 3 and 3 work. So the idea is that the square root of 18 is really the square root of 2 times 3 times 3, but the shortcut here is to look for pairs. See how there's a pair there?
Mm-hmm.
And for each pair, you can bring one out. So like, what do you mean by that? Well, there's 3 outside the square root, and what's left over is the 2. So all this side work over here, like you're supposed to have known this from a previous class, but it does come up again here in this class. So it's plus or minus 3 square root 2 is your answer.
Okay.
Let's do another one here. Related question here. So let's say it's like x squared minus 4 equals 20. And our goal is to isolate the x squared. Okay, so how do you get x squared by itself? What do you undo here?
You add 4.
You add 4 to both sides, yeah. So your x squared equals 24. Like, all right, great. To undo x squared, you take a square root. You're going to square root both sides. When you take a square root of the right side, it's plus or minus. So this is another one of those problems where you have to write the square root off to the side here. So the first number you try here is 2. Does 2 go into 24?
Yes.
Yes, because it's easy. It's even, right?
Mm-hmm.
2 times 12. Okay. And this is a better example because you actually try 2 again. Like you keep trying the prime number until it doesn't work anymore. So does 2 go into 12?
Yes.
Yes. And 2 times what number gets you to 12?
6.
6. Okay. And then you try it again. Does 2 work? Does 2 go into 6?
Yes.
Yes, 3 times. Okay. So the numbers on the outside are considered your leaves, and you look for pairs. Do you see how there's a pair of 2s?
Yes, I do.
But there's not any more pairs because these don't go together. So for each pair, you bring that number out. So you bring the 2 out, and it's the square root of whatever's left over. Okay, so what's left over is 2 times 3. That goes in here. And you reduce that by multiplying them together. Okay, so let's have you try one here. I want you to try reducing. This is just reduce. You're not solving. Reducing the square root of 28, please.
Square root of 28.
Yes. Just like we've been doing with that building that factor tree.
Okay, screw. I'm gonna go grab my sheets.
Okay, sounds
Right
good.
back. Five, 2, 5?
Okay, start
Yep.
with 2. Does 2 go into 28?
Yes.
Okay, what number goes to the right here? 2 times what gets you to 28?
Um. No. Is it 5?
It's not 5.
Okay.
Like, I'm really asking, what is 28 divided by 2?
Oh, um. 14.
14, good. Okay. So now does 2 work again? Just keep trying the number. Hopefully it
Yes.
works. Yeah, it does. Okay, so what number goes to the right there?
7.
7, yeah. Now you stop when you get prime numbers on the outside. They should be small enough that you'll be able to recognize them. Do you have any pairs?
Oh, yes, the 2s.
So what do you do with the 2?
You put it in a box.
You bring it out,
Oh, bring it out. Okay.
bring it out. Okay. So it's 2 square root. What's left over?
7.
7. Very good. Okay, let's have you try another one here. I got to be careful here that I choose ones that are work nicely for us. Square root of 48. Let's try that one. I want you to reduce that. So start with 2. What is 48 divided by 2?
24.
24. And you try 2 again. Does 2 go into 24?
Yes.
Okay, I agree. So what is 24 divided by 2?
4 divided by 2. 12.
Okay, and you try it again.
2 and 6.
Okay, and does 2 work again?
Yes.
Okay, what goes here on the right? What is 6
3.
divided by 2? 6 divided by 2 is
3.
3. Do you see any pairs?
Yes, I see 2.
Yep, there's one pair of 2s and there's another pair of 2s. And for each pair, you bring one out. So it's 2 on the outside, 2 on the outside, square root of what's left over. What is left over?
3.
3. So you multiply the numbers on the outside for square root 3. Okay, so let's take a look at one of your problems here. You've got a problem here. It looks something like this, like x squared minus 128 equals 0. It says to solve. Whenever you're solving one of these, you want to isolate x squared. So what do you need to do to isolate x squared here?
You add 128 to 108 and 0.
Yes, so you get x squared equals 128. And now you take a square root of both sides.
Okay.
Okay. On the left, it's just x, but on the right, you have to reduce this square root of 128. So I'd like you to try that for me, please. It's a little bit longer, but just keep using 2 until it doesn't work anymore.
Um, is it 32?
Well, just Jeremiah, just like the previous problems, you're gonna have a number outside the square root and a number inside the square root. And so like what I was looking for here is for you to break this down, like 2 and 64. Did you try that?
I did not.
Okay, you cannot guess these. I mean, you will, I mean, if you did like 1,000 of them, you'd probably see the pattern, but you have to work this out. This is like, you watch your instructor throw a punch or something, like you got to try it. And you're like, oh, that's how it is. I'm asking you to try this.
Okay.
And if you have questions, please ask. But,
Okay.
but I want you to see if you can work through this part of it on your own, please.
Okay. Uh, 32 and 2.
So it's important that the 2 remain on the outside on the left for visualization. The order does matter, just so you keep track of what you're doing.
216.
Okay, yeah, keep going here.
2 8.
Okay,
2 6.
they got to multiply, not add up to.
Oh,
Multiply. So what goes to the right of this 2 down here? It's
4.
not say 4. Okay, and then last one,
2 2.
2 2. Now you circle pairs. There's a lot of pairs. It's like, I don't know if you fold your own socks, but you got a lot of socks here. How many 2s? How many pairs do you have here?
3.
So for each pair, you bring one out. So I wrote 3 2s there. 1 2 3. Square root of whatever's left over. What number is left over?
2.
2. So this reduces to plus or minus 8 square root 2. Okay, let's look at another problem here. Okay, so new problem here. The goal here is to solve for n. Okay, so we want to isolate n squared. What is the math step to do that?
You have 4 2 4 and 77.
That's right. So n squared equals 81. What is the next step to solve for n?
Divide 1 by 2.
What did we do in this right here? What does this symbol mean?
Oh, square.
Square root. This 2 means square. Square root is this symbol. The
Okay.
little thing. So just have to make that clear. It's a language thing, right? That means squared, square, squared, I don't know. This means square root. So you're gonna take a square root of both sides. Plus or minus the square root of 81. Okay, so I'm gonna write square root of 81 over here to the right. Does 2 go into 81?
No,
No. 3 does. It becomes 3 and 27. So remember I mentioned you just keep trying the number.
yep,
So 3 times what gets you to 27?
9,
9. And then do it again. Does 3 go into 9?
yes, 3 times.
Okay, so you've got 2 pairs of 3s. So how many 3s do you bring out?
2,
2. So it becomes plus or minus 3 times 3 square root. Well, what's left over? There's actually nothing left over, but we'll put a 1 there for the moment. And maybe you're just like, oh, I should have known that. The square root of 81 is
9.
9. All right, let's look at another problem here. If you need time to get this down, I'm sorry, please tell me.
Oh no, I'm good.
Okay, 4x squared minus 6 equals 74. Okay, so the instructions say to solve for x, you have to isolate the x squared. Okay, so it's actually a 2-step process here to do that. You first undo addition and subtraction, then you undo multiplication and division. So you're first going to add 6 to both sides of this equation. So 4x squared equals 80. Now, there's a question to you, Jeremiah. How do you undo this multiplication by 4?
Divided by,
Divide by 4. Divide
Yeah.
both sides by 4. So what do I put on the right-hand side?
20.
20.
Oh,
Yeah, it's already there. Just seeing if you're paying attention. I know you are. It's just so we're what is the next step here? How do you undo a square? We've been doing that in every problem. How do you undo a square?
you subtract it.
Okay, what did we do in this problem up here?
Square root.
Square root. So a square root undoes a square undoes a square root. So you're gonna take a square root of both sides. Square root of x squared plus or minus the square root of 20. Okay, so the square root of 20 is not a perfect square. I'd like you to take that square root of 20 and figure out what it reduces to.
Ten. 210.
Okay, help me out here. Did you build a factor tree?
Yes.
Okay, what goes in the first two positions?
First one goes to the R110.
Okay. You're supposed to try 2 again. Does
5, 2, 5.
2, 5. Are there any pairs?
Yes, 2 2s.
Okay, so a 2 comes out. What is left over on the inside?
5.
So it's plus or minus what goes on the outside of the square root?
2.
Square root of what goes on the inside.
5.
Very good. Okay. Give me some feedback here. What about this is challenging you at this point?
Well, mostly when it comes to like the square root of like bigger numbers than like 20. That's pretty much it.
But this factor tree, it's very what's called iterative, means you just repeat the same thing over and over again. Like you have to be able to like, okay, I'm gonna try 3, I'm gonna try 3, try 3. All right. So let's do a couple more of these. Let's do the square root of 45. And your prime numbers here that you might need are on the right. Okay, so try reducing this one for me, please.
So the tree is
Yes.
5, 9.
Okay.
Yeah. That's it.
Okay. So while what you did is true, you start in order. Like you don't get to pick the one that you like. You start with 2. Does 2 go into 45?
Yeah, no.
No, it's odd. It's odd. 2 only goes into even numbers, but 3 does. And here's how you know that 3 does. The digits 4 and 5 add up to 9. Okay, so what number goes over here to the right? 3 times what number is 45, or what is 45 divided by 3?
15.
15. So you try 3 again. You're like, maybe I'll get lucky here. Right? Like if you got an opponent and
5.
something works, you try it again. You try it again until it doesn't work. 5, right? Are there any pairs?
Yes, with 3s.
So a 3 comes out, 3 square root of what's left
5.
over. Okay. Now the way you were doing it works for this problem, but you want to be careful that you're doing something that will work for every problem. So let's try one more here. I want you to try reducing the square root of 50. And please start in the order here on the right.
Okay. On the tree, 2 and 25.
Okay.
Uh,
2 does not work anymore, so you can cross it out.
Okay. It's
Does
not
3
good.
work?
Uh,
So you add up the digits 2 and 5. That's 7. 7 is not a multiple of 3, so 3 is out.
yeah.
So does 5 work?
Yes, it does.
Okay. Do you have any pairs?
Yeah, 2 5s.
So what do you bring out?
5, then the square root is 1.
What's left over?
Oh, 2. Okay.
Sometimes it's all the way up there. Okay. All right. Now, really quickly here, and unfortunately, we're not going to be able to, the lessons are just going to get slightly shorter. I want to look at one last problem with you. There is one possible exception that you will see, and I'll show you that here with question 4. And that'll probably take us to the end of our lesson here. So let me snip this in. It says to solve this quadratic, and you're like, all right, I know what to do here. I've been doing these, with Matthew here for the last half hour. I'm going to subtract 38. So you have x squared equals minus 22. The thing with the square root is the square root, you have to have a positive number or 0. So if it's a negative number here, when you try to take the square root of a negative number, this is not possible.
No, no solution.
No solution. Right now, it's not possible. No solution. So it's not, and it's not if the number is negative. It's when you get to the x squared part. And the reason is we did a problem earlier. This will be my last comment before we close out. We did a problem earlier where, yeah, it was -7 on the right-hand side, but after you added 25, it was okay. So you have to get that x squared solved for before you make that determination. All right. Well, that is probably it for tonight, Jeremiah. Encourage you to retry this assignment. I think you'll get a lot more of the problems correct. And I'll see you next week. Hope you have a great weekend. And thanks again for letting me help you. See you next time. Bye now.
See you next time. Bye.